All right, so in the last section, 3.4, you learned about graphing a system of linear inequalities, and you found that the solution to that system was where there were intersections on the graph, you needed to indicate those vertices. You need those vertices in order to solve this next lesson. We're doing today what's called a linear programming problem, and a linear programming problem was something that was actually invented around World War II to help solve problems in businesses and look at models for how they would distribute goods and services. And what we use it for today is determining the maximum and minimum values for any particular kind of incident. And in order to do that, you have to have a system of inequalities, which are considered the constraints, and you need an objective quantity. That's the problem that you're trying to find the maximum or minimum for. It's like, you'll find this in a word problem. I won't distract you right now, I'm sorry. So we solve it by graphing the inequalities or the constraints. We find the vertices, we substitute the vertices into the objective quantity, and then the least value is the minimum and the greatest is the maximum. So here's a look at a problem. We have a situation here that is our objective quantity. It's what do we want to find the minimum and the maximum for. And here are our constraints or our linear inequality. And so I've gone ahead and graphed that for you. I went ahead and changed this one to slope-intercept form. And I know that anywhere x is greater than or equal to 0 has to be above the line. Y is greater than or equal to 0 has to be to the right of the y-axis. So that's this one. And then I graphed my line. -1 is my slope, so I have a lean to the left. And my y-intercept is 6, so I went up to 6. I came down 1, back 1, down 1, back 1, because 1 over 1 is my slope. So I know that my ordered pairs, or my vertices, sorry, are 0, 0, 0, 6, and 6, 0. So now if I want to find the least and the maximum, find the minimum and the maximum for this problem, all I have to do is substitute in. So I'm going to take my objective quantity and I'm going to substitute in my ordered pair. And I find out here that it's 0 because 4 times 0 is 0, 5 times 0 is 0, 0 plus 0, 0. Now I'm going to try 0, 6. 0 plus 30 is 30. And now I'm going to do 6, 0. 24 plus 0 is 24. And so that tells me that my maximum is when my values are 0, 6, and my minimum is when my value is 0, 0. Now, most of what you're going to do is practice with a problem that's the objective quantity and some constraints. There are only a couple problems you're going to have to solve a word problem for, in which case you'll need to determine what's the objective quantity, and you'll figure out the constraints based off of the other words in the problem. So I want you to go ahead and give this one a try. Either press pause or turn it off now, otherwise I'm going to go ahead and solve it. Alright, so x is greater than or equal to 2. X is 2 right here, so it's an equal to, so I'm going to create a solid line. X is less than or equal to 5. Again, a solid line. So x is greater than 2 is on this side. X is less than 5 is on this side. So right now I know I'm dealing with the region in between my lines. So let me do y is greater than or equal to 1. Greater than is going to be above. And y is less than or equal to 6. That's going to be below. So I'm talking about this region right here. So my ordered pairs are 2, 1, 2, 6, 5, 6, and 5, 1. And I'm going to put those values in my objective quantity in order to find my maximum and my minimum. Six plus 4 is 10. 6 plus 24 is 30. 15 plus 24 is 39. 15 plus 4 is 19. So here's my maximum, which is 5, 6. And my minimum is 10, which is 2, 1. All right, go get on that assignment.